So let me start with introducing the panelists. I'll start with, at the end of the table, Mehran Sahami. Mehran Sahami is a professor and associate chair of education in the computer science department at Stanford University. He's also the Robert and Roth Halperin University Fellow in undergraduate education. Prior to joining Stanford as a faculty in 2007, he was a senior research scientist at Google for several years. His research interests include computer science, education, machine learning, and web search. Thank you for being with us. Amirali finished his bachelor's and master's degrees at Sharif University, working in the application of various artificial intelligence algorithms in computational fluid mechanics. He then started his PhD at Stanford University, where his focus was high-performance computing and developing fast algorithms with applications in computational biology. He started his career at Illumina by joining protein engineering group to apply machine learning algorithms to enzyme engineering. He is now a senior manager at Illumina in the computational and applied biology department, leading deep learning group. The focus of his team is to bring new AI algorithms to genomics and Illumina's internal technology. Thank you. Mohammad Shoeybi studied mechanical engineering at Stanford University and received his PhD in 2010. Since then, he has worked at Cascade Technologies, Nor1, Jetlore, and Baidu, mainly focusing on developing models, efficient and scalable algorithms, and software for end-to-end machine learning systems. Mohammad is currently the team lead research scientist at Baidu, Silicon Valley AI Lab in the applied machine learning team. His mission is developing new AI technologies using world-class deep learning-based speech and language technologies and applying cutting-edge AI to improve the experience of Baidu's users. Thank you. And last but not the least, Nima is a Sharif and Stanford University graduate and former co-founder and CTO of CleverSense, acquired by Google in 2011. Since then, Nima has been working on various machine intelligence related projects at Google. He is currently an area tech lead for machine learning in Google Maps. Thank you all for being with us. So I'd like to invite each of you, starting from Mehran, to give their statements on what they're working on and their focus, and how their work relates to machine learning. Thank you.
Oh. Thank you very much, and thank you for the opportunity to be here this afternoon. The work that I do is, as was mentioned, is primarily on education, and so I grew up in sort of the machine learning world, moved into the education world, and now the way I think about it is I do machine learning for human learning. And the idea being that, for probably about the past 1,200 years, we've done education roughly the same way, which is usually there's a person who stands in front of a room of people and lectures. And if our greatest innovation in education the last, 1,200 years was the advent of PowerPoint, then we have serious problems. So what we really need to do is we need to understand how people learn, what is it that makes them learn efficiently, what are the things that are barriers to learning, by understanding what they actually do. And one of the things that we can do now because of computing technology is to be able to instrument the process by which people go through an activity to learn. So I'll just give you an example. When someone's learning to program, which is the area we started in because that's one of the things I teach is programming, is how do people actually program? What do they do? What are the errors they make? If we could actually understand what they do rather than just the final product of what they turn in, we can understand where they're having difficulties, how we could make that process more efficient, how we could basically change the concept of education to just be what one person thinks people should learn, to using that data to understand how people are actually learning and then potentially modify the educational process. So the way we use machine learning in that is we take this data, we build probabilistic models of the kinds of patterns of behavior that we're seeing, and then try to use that to inform us about what's actually going on in the educational process. There are some other things we do also around optimization to understand. In other educational contexts, there's been some examples for, say, in mathematics, to try to understand how do students master a particular topic, rather than just we're going to spend 2 weeks learning algebra and then we're going to spend 2 weeks talking about, variation. We're going to spend 2 2 weeks talking about change of units or whatever. How much time do people really need? What are the factors? What are the related topics? If we can, again, build models of that to understand how these things are related to each other, we can actually let the data drive education and make the educational process much more efficient. And so that's what we're working on. Still early days, and we have a lot of momentum in the way of how education used to be done for several hundred years that we need to overcome. So it's a big problem. As Amin referred to, education isn't just about the transmission of information. It's about all the social context that goes around with it. And so that's one of the other challenges, is anytime we think about machine learning, it's not really a machine learning problem. Machine learning is just a technology we're trying to use to address a much larger social problem.
So thank you very much for the invitation. It's honoring and humbling to be here among all of you guys. I'm working at Illumina. For those of you who don't know Illumina, Illumina is a company that makes devices that sequences DNA, as well as offering other services. But the focus is on devices that sequences DNA, opens up doors in genomics. And why is it important? Because genomics and being able to do DNA sequencing is probably the very first step for precision medicine and personalized medicine. Amirali, the other Amirali, interestingly, he talked about their approach and the application that they have in treating cancer. I wanted to give you one very tangible example that always touches my heart when I read through that how these technologies can import and change people's lives. There was this boy, Joshua, a 14-year-old boy, that he started having seizures, pains, to the point that they had to hospitalize him more than often and have induced coma so that he doesn't suffer from pain. For many, many years, they tried all sort of different technologies that you can do to scan different measurements, medical measurements that you can have, and none of them led to any sort of answer. And eventually, his file went to a bunch of scientists, I believe in the Scripps Institute in San Diego, maybe some other place, I don't remember exactly. And then they did sequencing of the bacteria in the spine that he had, and then it turned out that there is a small bacteria, and the solution was a simple penicillin. Everything was solved. So that is how important this field is and how we can change lives. But it is very, very much early on. When first people did the human genome sequence, the complete human genome sequence, it is not exactly complete, but as far as they could go. The scientists, they knew what 2% or 1.5% of the genome is doing, and they couldn't figure out what is the 98%, what the rest of the 98% is doing, and they called it junk DNA. It wasn't too long ago, maybe 20, 30 years ago. And then further research was happened, and it turned out that actually that 98% is fairly important. So biology and evolution is doing its job fairly well. The role of the group that I am in is the deep learning and AI team within research department of Illumina. We are trying to apply these techniques to better understand what is happening with in genomics. We are very early on. Nobody really knows what is happening, and I'll give you better examples later on. But let me ask you this question. How many of you has done any sort of genome sequencing? 23andMe. Oh, nice. That's a good number of people. I hope that all of this is 23andMe, because if it is not 23andMe, usually if you've done DNA sequencing, it's not good news. It means that you are suffering from some sort of a weird problem that nobody knows how to solve, and you ended up doing DNA sequencing. And we really have to change that. I can easily see in 10 years or 15 years that you would do more DNA sequencing as part of your annual check, or even more often, maybe monthly or weekly, your microbiome, gut microbiome, skin microbiome, oral microbiome, immune repertoire, as well as your whole genome sequencing, and that would be part of your healthcare, and it's coming, up and coming. It's just up to us to figure out how to do that. Why is it a challenge? So people who do AI, and they would talk about it, like one of the biggest breakthroughs recently was creating algorithms that can identify a cat from a dog. I would really encourage you to go and talk to somebody and try to give them a way to identify a cat from a dog out of a picture. And it is actually a very challenging problem. You quickly come to a halt. You don't know how to tell them, just by looking at the picture, identify cat from a dog. But somehow human brain knows how to do that. But then for us humans, cats and dogs and images and voices and speeches are things that we are living with and we are very familiar with. When it comes to genomics, which is a sequence of bases, A, T, C, G, just 3 billion bases, we have no idea. Literally, we have no idea. When they do a sequencing of a person, for example, let's say a kid that has a rare undiagnosed genomic problem, that person, probably if you compare the genome of that person to any of you guys, there are 3 million different points. And probably just 1 to 4 of them are the ones that is causing that problem. And you have to figure that out. And if you give that to an expert in the field, a genetic counselor right now, it may take up to 14 hours or 20 hours, and eventually they couldn't figure out. Like the yield is something around 50%. 50% of the time they have no idea what happened. So it is important to bring the new techniques, especially the new techniques in genomics, in deep learning that goes end to end. It has been extremely helpful. We've been applying it to our field, and we can see the difference that it's making. But still, there is a long way to having products because of regulatory affairs, and also the problem that the margin of error in healthcare is very, very little. Like you can identify a cat as a dog and nobody dies, but you cannot identify one disease as another disease or sort of miss a point, and there would be severe consequences. I'll stop here. I have other things about AI in particular in healthcare, but I hope that people would ask questions and I would go ahead. Thank you.
Well, thanks for the opportunity to be here, and I would like to take the moment and thanks the organizers as well for putting a lot of effort. I've done these things before, and I know how much time and effort it takes. So thank you so much. So as Milad mentioned, I'm part of Baidu's Silicon Valley AI Lab. So we're focused on speech and language technology. And the reason is actually we're focusing on this is one of the missions of our lab is there has been a lot of like touch points when you go and you want to type, you actually use your fingers, you go home and then you turn on the TV, you turn off the lights and all those. And when the technology advances, actually we want to have a more seamless interactions with our surrounding environment. And one of the missions of our lab is actually speech is the way to go, is a good replacement for a lot of touching points that we have. We have in the car, we have at home, we have at work. And so speech is actually not a recent problem. There has been 20 to 30 years of good research going on, and there has been a lot of activities in the field. But with the deep learning and the methods coming in, and also the whole computational horsepower that was behind it, is actually it brought a fresh blood basically into the system. And and then we felt at the lab at Baidu's AI lab that this is something that is going to change the user's experience, and it's going to have a lot of impact. So just to give you a brief kind of type of problems that exist, I thought it would be good to go with something very tangible. A lot of us today have either Google Home or Amazon Alexa, and we're working with it. And I just want to touch on some of the problems that exist, and my lab and other labs are actually working on, and all of these are actually active areas of research. So when you have the device sitting at home, you start talking to it and say Alexa or Google Home or Cortana. And so it's a neural network that is running in the background constantly 24/7, and that actually listens and tries to detect those keywords. So that's actually a super tough problem. A lot of people are still working on it for two main reasons. There's actually a lot of noise. There's a lot of false positive that can happen. It's actually in a room that people talk to each other, and also this is constantly running. So the power is important thing. So it's really important to be really efficient as well as high performance as well. So as soon as the device wakes up, you start talking to it. And at that point is actually there is another network that takes over that. And you basically stream the audio to a server, and it tries to understand what you're saying and try to make decisions. So that's actually called the automatic speech recognition, which basically is another area that deep learning has had a major impact, and it's basically a revolution in that. And then after that comes up to the system that needs to make a decision, needs to interact with you, and that's kind of the language processing part of it, or natural language processing, or the natural language understanding as well, which is super tough problem, honestly. To date, there is no good solution. There is actually, even academia is struggling with that. And I personally believe among all these home devices, whoever solves the NLU problem is actually going to be the winner. So, and then you got to make a decision. You got to keep the dialogue going. So that's another piece that actually NLP has had impact on it with recent activities, with a lot of data that became available as well. And after that, the device needs to interact with you as well through a human sounding voice. So that's another active area that is actually we're working on as well. And you got to be able to generate human sounding voice from the text or something that you have decided, and their emotion is important. The voice that you pick is important, how the dialogue is conducted as well. And like you can see, like even for a simple device that today we interact, and I know there are a lot of deficiencies, and believe me, everybody is actively working on these things, is like there are a lot of different elements. There are a lot of different elements that is still like in academia also people work on. And just want to circle back to what the role of machine learning. Machine learning has existed before, and a lot of people have worked on it with a lot of feature engineering, and you needed to get a PhD in the field and work for 10 years. But what deep learning specifically has enabled us is actually remove the barrier to entry, in a sense that you don't need a lot of those traditional feature engineering. You don't need a lot of knowledge base. A person like me that comes from mechanical engineering background is actually with some research can get started and try to improve these systems. And also it has enabled us to use a lot of the structured as well as the unstructured data that is available today to actually bring it and try to improve it. And I feel like hopefully with the help of deep learning and with the help of the computational power and with the help of a lot of companies, including Google, including Amazon, including Baidu, that put into this, hopefully the speech can become accurate enough that is like a replacement for the touch interfaces that we have.
It's wonderful to be here. Today I'll talk about a little bit about the present, what we work on today at Google, and also a little bit about the future, like where things are going. So I'm part of the Geo Platforms team at Google. This is the team where our mission is to build an accurate model of the world, of the physical world around us. So why is that important? We humans need to plan our lives in the physical world. So having access to a model of the physical world that accurately reflects the facts about where things are, how things are connected to each other, and what is happening in the physical world, that's very useful for planning things. And I'm sure many of you have heard of Google Maps. So that's ultimately the product that we are building. And we are constantly working to keep it accurate and keep it complete, a complete reflection of the physical world. So part of the reason for having this model is the value to humans, but also increasingly having this model is being used more and more by the machines for various purposes. So for example, one new area is using this map of the Earth in order to do different types of analytics. So this can be geological analytics, economic analytics. So different types of analytics that can be done by processing this huge amount of data. The other area, which is there is a lot of hype around this today, self-driving cars. they definitely rely on a model of the physical world in order to be able to navigate throughout the roads. So that's the reason for building such a model. Now, how this actually happens, to give you an example. So for example, suppose we want to detect all the speed limit signs all around the world to understand what is the safe driving speed on each road, in order to show that to the users, give them accurate navigation times, and so on. How would we do this? So what happens today for solving this problem is that we have a global operation that essentially we have thousands of vehicles that we drive around the globe on all the streets around the world. That's called Street View, Google Street View, which some of you might have seen. So we take a lot of imagery of everywhere, basically. We have really good coverage in most areas of the Earth, except for some countries where there are issues with regulations and governments, such as India and probably China. So we collect all of this dense data, which is all pixels, so visual data. Then we need to extract what we are interested in, the speed limit signs. So how this happens, we leverage human operators in order to first label a limited set of images. Currently, I think around 100K examples of exactly telling us which areas of these images are actually speed limit signs. And to generate this labeled data set. Then this labeled data set is used in order to build machine learning models, deep learning models. So we use this to train these models that can essentially scale this, the ability that humans have for detecting these patterns, scale that to everywhere else for all the millions of other signs that we need to detect. So then this model is now scalable to everywhere and is productionized, and the results of this, the semantic knowledge that's extracted, goes into the Google Maps. So that's the current state of things, so essentially building the Google Maps model is automated to a large extent. All of the things that you see, all the businesses, all the road segments, all the buildings, all of these are generated by automated pipelines. So this is the state of things today. So going into the future, one of the challenges is that capturing all of this dense imagery data is very costly, and it takes a lot of time to do this. So right now, the cadence of collecting this data at best is about 6 months. So it takes 6 months to collect a new round of fresh imagery for any country. So that's kind of slow. So that means we can only sense the world every 6 months to get a refresh. So how can we make this better? So going forward, the idea is, instead of relying on only a few thousand cars that have really high quality cameras, can we leverage millions of cameras that are already out in the world? Lower quality, but there's 1,000 times more of these cameras. So cameras that we have on all of our phones, or increasingly cameras that are in the vehicles driving around. So the idea is scale the sensing of the world by distributing it across millions of cameras. And then that brings up the challenge of how to actually transfer all of this data, how to do computation on this to extract the semantic knowledge. And the trend that we're going toward is pushing computation, pushing the ML models to the edge, meaning actually do the ML inference, not in the data centers, but increasingly on the devices that are the sensors themselves. So that's the edge machine learning that we're pushing toward. So that's one of the trends that I think will help us scale this a lot more and get to a cadence of close to real time of sensing the world and reflecting into our model of the world.
Thank you so much for the detailed explanation of your work. It's very interesting to me because the first thing that I feel I came out of this diverse set of backgrounds is that, well, machine learning is a horizontal technology by definition, and it applies to all sorts of verticals, and we have just witnessed a few of them here. But it also sounds like the advent of AI and the penetration of it into different fields has experienced different speeds. On the internet front, where we had this abundance of where we had this vacuum of regulations, there has been a lot more of growth, whereas in other fields there is a different speed and pace. So I wanted to kind of get a sense of your understanding about the roadblocks for the expansion of AI and adoption of it in each of your areas. So if each one of you could comment on that, that'd be great.
Since it's the panel on pattern recognition, maybe we just keep the same pattern of answering questions. I'd say in a lot of things, I mean, if you look at the speed of how AI is having an impact, a lot of it has to do with things like availability of data and the regulations around what kind of data you can get, right? So if you're actually dealing with, say, humans that you're getting data from as opposed to getting data from machines, that makes a big difference. So being able to get data from images or, say, from sensor data from cars or whatever the case may be, there's much less regulation, much higher availability, much higher throughput than when you want to get data from a human being or from a controlled trial in medicine or whatever the case may be, things, right? So I'll give you a simple example. Why don't all mortgages self-refinance? Right, it should just make sense, right? It's a simple algorithm. Just when interest rates get low enough, the price of refinancing the mortgage should become cheaper than any fees involved, and it's just do it, right? It's actually my 11-year-old could write the code to do that. The reason why we don't is because there is a huge amount of interest in the financial industry to maintain friction around things like that, because that's how they generate a lot of their profits. So in a lot of cases, in terms of thinking about technology penetration, it's not because the technology doesn't exist. It's not necessarily because of, in some cases it can be data, but not necessarily because of data issues, but because there are large institutions and social phenomena that feel threatened by the fact that technology comes in to automate a particular process. Another example, and this is an actual historical one, right? 30 years ago, there was an expert system developed at Stanford to do blood diagnosis called MySyn, right? An early expert system, early example of AI. It was actually better at diagnosing blood disease than world expert doctors, right? So they actually did a controlled trial that did better than all the residents, all the med students, and all the expert, doctors who did this. How many hospitals in the world is this system used in to diagnose blood disease? Exactly 0. Right? Why should that be? Well, part of it's around regulation. Part of it's human. We don't want a machine to tell us that we have a terminal illness. Right? We want to have a human being there to provide that diagnosis for us. So part of the interesting thing is we have our own biases also around technology. Another one is self-driving cars. If you look at the social aspect of it, there's always a question I ask my students is how many of them are worried about getting into a self-driving car? And probably about half the hands in the room go up. And I ask them how many of them flew to Stanford? And most of the hands in the room go up. And I say, how many of you flew the plane to Stanford? And none of the hands in the room go up. And I say, guess what was flying the plane most of the time? A computer. Because in fact, most of the time the plane is on autopilot, right? So, but we're not used to flying our own plane. So there we have made this trade-off where we accept that social issue. We are used to driving our own cars, so we have not made the trade-off to accept that social issue. And so people make a huge deal in the press when there's something where there was a self-driving car, it got in an accident. There's one. It got in an accident. That made front page news, right? Every day around the world, there are millions of human beings involved in car accidents. That doesn't make news at all because we're willing to accept our own fallibility. We're not willing to accept that fallibility from machines. And that kind of friction actually impacts the adoption of this sort of technology.
So I think I can pick it up there. Many of the points that I wanted to make, Mehran put them in a very nice abstract way. I give you a few examples. Availability of data is a big issue in healthcare. Let's say you want to make a connection between the genotype and phenotype. By phenotype, I mean the disease or the certain condition that you have. There is a lot of privacy around the EHR and EMR electronic health record that you have that different places won't let you get these things connected. So that's one thing. Another problem for healthcare in particular is that labeling data. Like when you're looking at images, you can hire 140,000 something people, and they say that this is a sign, this is a sign, this is a sign. We hire the best in the class doctors, and they have no idea what you have. Like there is 30% error rate right now. If you've been recently to a doctor, take it with a grain of salt. And so that's another problem. There is a lot of noise involved. For the other issue in healthcare, there are a couple of other issues. One is that there is this education gap. You have to literally go and educate physicians that have been doing this for many, many years. And we already are seeing that, and I can make this prediction fairly strongly, that anything that has to do with image processing, X-rays, MRIs, and things like that, the doctors in that field, and they know it already, their job is not very, they are in a very shaky position, but still there is a lot of room for AI to come. There is FDA, there is regulations. As I said, there is very little margin for error in these cases. And the last thing is incentive. I'll give you an example. If you want to put together an AI for a healthcare system, you want to implement it in a hospital, who do you have to talk to? You have to talk to the CMIO of that hospital. That CMIO is getting a hefty salary, maybe $800K a year, and his job is to approve or not approve. If he wants to approve, he has to put together a team, take the risk of implementing this new technology in the hospital, and maybe it works, maybe it doesn't work. If it doesn't work, there is a lot of blame on it. And what happens if it works? He still receives like $800K a year for his salary. Nothing really changes. So the best answer right out of the bat is no. Right? Unless there is something really not working in their hospital and they want to make a change and they want to take a risk. So this incentive also is another issue, and because of that, everything is very, very slow in healthcare. And one of the problems that is happening is that AI startups in healthcare, they have a problem. Because they are burning money and everything is slow on the other end, so they have very little chance to make it. But big companies like Google, Facebook, and those companies, they have a lot of room to absorb this delay. So that's why I personally think if you want to look into the future, that the biggest things in AI for healthcare probably is coming out of big companies that they can absorb the delays rather than small companies. They're going to just burn the money and then go away without anybody hearing about them.
So, yeah, definitely. I think a lot of points already covered. So in this industry that I'm part of, regulations are less of a problem. Still, data privacy is super important, but I mean, apart from that, there are not that many regulations. But the problem exists right now is the cost and like kind of the monopoly, because first of all, data is super expensive. Even like, I mean, if you want to get 100,000 people to basically label your data, it actually costs a lot. So there are just few companies, Google, Facebook, Baidu, and a few of them that actually hold really good data sets. And especially with the deep learning approaches is actually, I mean, they actually basically built on huge data sets. So it gives them a huge advantage, just few companies. And it's It's actually is a problem for smaller companies to get into it, and also the cost of the computation is a lot. Like, I mean, for one of our models, we use around like 32, 40, 64 GPUs for a month to train these models, and not every company can actually afford those. And these are like a lot of iterations that needs to go through, and also expertise as well has been limited. So I think the challenge is like kind of democratizing or just bringing this into more of a mainstream, so a lot more people can work on it and try to actually innovate.
I just have two comments. So one on the data, I totally agree that we have an abundance of unlabeled data. There's a ton of data out there. But currently, with the supervised learning approaches that we like mostly commonly used, requires a lot of the labeled data, which is expensive to generate. So there is a trend right now in research toward building lower sample complexity models. So models that can learn from, instead of hundreds of thousands or millions of labels, models that can learn from perhaps few hundred examples. This is a trend going toward like getting inspiration from how humans learned. Kind of touching on what Mehran mentioned, we humans, we don't need millions of examples of a new concept to understand what it is. We can work with probably tens of examples or even few examples. So how can we move towards such models, such learning algorithms that makes it much easier, much faster to learn new concepts for the machine? So that's one comment. The other comment, I think there's a lot of industries where machine learning AI hasn't had a big impact yet. I mean, healthcare and areas that we work in, like vision and speech recognition. These are the common areas, but I think there's a lot of other things, other areas like agriculture, anywhere that we can sense the world, we can generate data from measuring a system. There is potential for applying these machine learning approaches. So that requires bringing people from both sides, from experts of the domain and also experts of the machine learning techniques to kind of come together and solve the problem in a better way. So hopefully we'll see more of that happen.
Yeah, that's right. So on the training of workforce in this field, there are a lot of questions. I remember that 2 years ago, when I was graduating, there was, if someone wanted to go to this space, they needed to have had heavy expertise of the field in order to kind of obtain a job related to machine learning and AI. And over the really quick, short period of time, the past 2 years, a lot of tools have been made, and it's become a lot of the barrier to entry for scientists has gone lower. And so that brings us to two questions. One is that how much expertise should current scientists who want to go to this field have in order to enter the job market? And what are their expectations? What do you think you can teach them versus what they should have from the get-go? And also, how do you see the future of this space? Do you think that people, there will be a surplus of resources in terms of human resources who work on this field, or we're going to need a lot of people coming in for the years to come? And I just wanted to remind you that we have about 5 minutes, so if you can be mindful of the time in your response, I would appreciate it. Thank you.
Sure. So to go really fast, I think machine learning is getting commoditized in the same way. If you look at the story arc for compute infrastructure, got commoditized over sort of the last 5 to 10 years, where, you know, if you wanted to do a startup 20 years ago and you wanted to scale, you had to build a whole bunch of scalable back-end infrastructure yourself. Now you just go and write checks to Amazon and buy their web service or Google Cloud or whatever the case may be. And there's still a set of people. There is still a lot of expertise that's needed to build those scalable systems, but now a few companies can build that infrastructure and a whole bunch of people can leverage it. I think that same story arc is being followed by machine learning. There's a bunch of experts who will build a bunch of models that then a lot of other industries will use, but there will still be the need for those experts to build specialized models. The one thing I would add to that is when I was in graduate school, which I won't even mention the year because I'm getting older, is we used to always say neural networks were the second best way to do anything. And the reason why they're the second best way is they're a universal optimizer. You can throw them at any problem and come up with some model. The first best way to do anything is to understand the domain and then figure out what's an appropriate way to constrain your model to address that domain. And so the advice I would give looking forward is don't just learn machine learning and some domain you want to apply it to, because the knowledge from that domain will actually make a big difference in the model building you do.
It's so good to be right after Mehran. Yeah, I cannot insist more than enough that hire somebody who has an understanding of your data type. People may end up being lucky, but don't get fooled with the fact that deep learning and machine learning recently had success on vision. We are all experts in vision. We can look and identify objects. As soon as you go into specific domains, my first-hand experience is genomics. If you don't have understanding of data type, you could be lost in a very, very crowded jungle and have no idea what you're doing. So that's one of our challenges, that should I hire a computer scientist who has no idea about biology, or should I hire a biologist who has a very good understanding of biology but not super good understanding of computer science? And unfortunately right now the combination is very rare. We don't have many. So maybe idea for you to study.
So I'm a true believer in fundamentals. So I think if you want to be in the field, again, in terms of like machine learning or in terms of, I don't know, machine intelligence or computer science. So if you know fundamentals really well, then I think there are a lot of opportunities for you. There are a lot of opportunities for impact as well. And by fundamentals, I mean, you got to know really mathematics, statistics, and also computer fundamentals, basically. So I mean, it's a very dynamic field. Honestly, we were talking before. I cannot say in 2 years where we're going to be, what is going to be popular or what is going to be working or not. Yet the jury is out. But I believe if you know fundamentals, if fundamentally you're a strong person and you open up your eyes and then you basically detect the trends, you can count on those basic fundamentals and then learn the rest.
Yeah, so I totally agree with all the comments. So I think machine learning is just one tool in the toolbox. And what we need is really, for solving technical problems, we need engineers, we need problem solvers. To just come in and solve the problem with whatever tool that's needed. So maybe machine learning could be one of the tools that you need for some problems to solve. If that's the case, then the engineers can actually learn the tools, and there's a lot of open source tools out there to do so. So I just see it as part of the tools and part of the process to solve problems.
Thank you so much. I hope that this demystifies some of the questions that people have about the AI and how the hype around it. With that, I'd like to thank you all for being part of this panel. Thank you for accepting our invitation. And thank you, everyone, for being such great audience.